Right, so we're looking at some inequality review. So here we've got some number lines drawn, and we want to write algebraic inequalities that define the inequalities shown. Okay, so we need to remember that the circle is a way of showing that the number that it's above is either included or not included within the inequality. So under the inequality, what do we know? Then we know that inequalities will involve that symbol, that symbol, that symbol, or that symbol, or that symbol not equal to. Okay, so basically we've got to say, well, 2 is involved, it's about x, so we know it's going to be x and something to do with 2. It's saying by the arrow that the numbers 1, 0 going on down to negative infinity will be included, but it's not including the value of 2, so the symbol will be that one, not included because it's an open circle. This one has also got about x, and it's got the number 2, but this time it is a coloured in circle, therefore it involves the 2 as well, so it includes it, and the numbers are getting bigger, so we must be looking for x numbers bigger than or equal to 2. This one is again about x and 2, but it's an open circle, so it doesn't include the 2 itself, so it has to be just as x is greater than 2, so it includes all the numbers 2.1, 2.2, 3, 4 and so on. This one is again about x and 2, but the arrow is showing that you're getting smaller than 2, but it does include the 2 as well, so we need the little equal symbol underneath the sign to show that it includes the 2 as well. Alright, so that's a quick reminder about number lines and their interpretation. This one says work out the smallest integer value, so under the what do we know, we must remember the word integer means whole numbers, both positive and negative. And it says satisfies, so in other words we've got to solve, so under the what do we know, and it's asking us to solve this. So when we solve the inequalities, then we treat them the same as an equation basically, it's just that we always keep the symbol involved within the inequality. So we're going to take away 3 from both sides, because we're trying to get the value of x, so we're trying to get x on its own. The inequality sign stays the same, 20 take away 3 is 17, then we divide by 4, so we get our 1x, so 17 divided by 4 is 4.25. So what this is saying is then the x values have to be greater than 4.25 to make this true. Our check would be to say, okay, what happens if x is 4? 4 times 4 plus 3 is 19, that fails, it's not bigger than 20. X equals 5, 4 times 5 plus 3 is 23, 23 is greater than 20, so basically we're showing that anything that is less than this doesn't work, anything bigger than this does work. So that's our kind of check. We then go back to the question itself to make sure we're answering what was expected. It says work out the smallest integer value. So this is saying x is greater than that, so if we had a number line we'd have 4.25 on here. We don't include the 4.25, but we do include every number going on, but it's asking us for integer values, so above 4.25 we'd have 5, 6, 7 and so forth. The smallest one would be 5. So the answer here, the smallest integer value would be x equals 5. That would be what would be put on the answer line. Okay, so that's solving. Got another solve here, but this time we've got the x on both sides of the inequalities. So the thing to do is to move the x's into one term, and then the numbers go together into one term, and then we can solve for x. I'm going to add 4x to both sides because the take away 4x looks smaller than the 2 x's. So I'm going to add 4x's to both sides. So that's going to give me 6x, take away 6 is less than 3, because negative 4x plus 4x is 0. I'm then going to add 6 to both sides. So we've got 6x's are less than 9. And opposite operations all the time when we're cancelling things out from one side of an equation to another, or one side of the inequality in this case to another. And we want to divide by 6 because we want to know the value of just x on its own. So 6 divided by 6 is 1x. The symbol stays the same. We're not dividing or timesing by a negative, so the symbol doesn't change direction. And 9 divided by 6 is 1.5. So solve. Our check Well, it says that x has got to be less than 1.5. So we'll check what happens with 2. This should fail. So we've got 2 x's, take away 6, and then we've got 3 take away 4 lots of x. So 4 take away 6 is negative 2. 3 take away 8 is negative 5. Is negative 2 less than negative 5? No, it's not. So that one worked. And then we try something that is actually less than 1.5. So x is 1. So 2 times 1 take away 6, less than 3 take away 4 times 1. 2 ones take away that is negative 4. 3 take away 4 is negative 1. Is negative 4 less than negative 1? Yes, it is. So our check worked. So we can be confident that we look so we've done the right thing. Always important to think about how you check your answers, guys. This one says solve the inequality. So again, it's about getting the x value on its own. The inequalities, though, just remember it's the same as solving equations. Technically, whatever you do to one side of the symbol, you do the same to the other. It just happens that we've got symbols in 2 places here. So therefore, we're going to have to do things to this side, this and this. So we're going to get x on its own, which means we're going to add 4 to every part. So negative 7 add 4 is negative 3. We're still going to have 3x. Negative 4 add 4 is 0. And 9 plus 4 is 13. We're then going to divide by 3. But again, it's to every part of the inequality. So negative 3 divided by 3 is negative 1. Symbols stay the same. 3x divided by 3 is 1x, so just x. And 13 divided by 3 is 4 and 1/3. Okay, so the x values have to be greater than or equal to negative 1, but less than 4 1/3. Okay, so again, the check, we could try 5, should fail. We could try negative 2, should fail. And then we could try something in between, 0, 1 or whatever. But that's how we would check it in the exams. Here's an inequality drawn at the number line. So write down all the integer values that obey this inequality and the answer to part A. Okay, so let's just do the what do we know. Well, it's about x. And this is saying that the x values have to be less than or equal to 3, because we include the 3. But it has to be greater than negative 2, but not including negative 2. Okay, so it says write down all the integers. So again, under the what do we know, that means whole numbers. And we've got to be careful, it's about both of these. So we look at the two, so we've got, and we've got, okay, so when we look at this then, our limiting factor is this one, because negative 2 is smaller than this, so we know then that x has got to be greater than or equal to negative 1. And our limiting factor on this side is the 3, because we have to have values that are less than or equal to 3. Can't include this 4 1/3 because it's bigger than 3. So that's our limiting factor. So basically it's saying then that all the answers that are possible will be between these two values. And it's saying write down all the integers that obey it. So we'd have to write down negative 1, 0, 1, 2 and 3. And we'd check in our minds, negative 1 goes there, no problem. 0, 1, 2 and 3, no problem. And we're not got any bigger than 3, so it will work for both inequalities. Okay, so this question talks about a rectangle, and it says you're given that the perimeter, so we need to remember under the what do we know that we add up all edge lengths and work out the maximum area of a rectangle. So under the what do we know, then we know that the area equals the length times the width. Okay, so we need an x value, don't we? Because it's got x's, so therefore we're going to solve. So we're given that the perimeter has to be less than or equal to 55. So basically we're going to have to add up the perimeters. So again, we add on to pictures what we know. We know that length will be the same for it's a rectangle, and we know that length will be the same for it's a rectangle. So we've got 3x plus 4 plus 2x take away 3 plus 3x plus 4 plus 2x take away 3. And it's telling us that the perimeter has to be less than or equal to 55. So let's go for it then. So we've got 3x's, 5x's, 8x's, 10x's. 4 take away 3 is 1. 5 take away 3 is 2. So solve that in the normal way. So divide by 10. Okay, so basically the questions come down to the fact that when we recognise the key language, it talks about perimeter and it's given us a limiting value. So we've worked out an equation, or an inequality in this case, that involves the information we've got, and we've come to the conclusion that the x values have to be less than or equal to 5.3 to make this work, so that the perimeter is less than or equal to 55. The question wanted the maximum area, so the maximum area will come from the biggest value of x. And the biggest value of x according to this inequality that it could be is 5.3, because we can include the 5.3 because of the symbol here. So the maximum area will come from multiplying 3x plus 4 by 2x take away 3, but we do know the value of x, so it'll be 3 lots of 5.3 plus 4 times 2 lots of 5.3 take away 3. Okay, so 15.9, 19.9, 15.9 plus 4, 19.9, and 10.6 take away 3, 7.6. So we're going to end up multiplying those two. So 19.9, whoops, 19.9 times 7.6 equals. So 151.24 square centimetres, because about area, and area units must always be squared. Okay, so we created an inequality to allow us to find a value of x so that we could use that to work out the maximum area. The maximum area must come from the biggest lengths, so therefore we need the biggest values of x to make that true. And we went through and put those numbers into what is the formula for calculating the area. So that's how that question could be done, by just thinking about the key words, thinking about what they mean, and then writing the information about that in terms of x, and then coming up with an answer.